So we want to calculate this sum here, but if you were to write out the terms, what you'd realize, as written, it's not a geometric series, so be careful. What we need to do to help ourselves out is split this into two sums, because we can split a summation over addition, so n equals 0 to infinity of 3 to the n over 4 to the n, plus the sum from n equals 0 to infinity of 5 over 4 to the n. And now what we have is the sum of two geometric series. Just rewrite these just slightly just so we can make things real obvious. 0 to infinity. I'm going to rewrite this as 3/4 to the n. So we see this has a common ratio less than 1. Plus summation from n equals 0 to infinity of 5 times, we could write this as 1/4 to the n. That's the fourth, excuse me, the n. And this also has a common ratio less than 1. So we're going to do those sums separately. And the biggest thing from this point on is you just got to be careful about what your first term is. In this case, since we're starting at 0, plugging 0 in, this gives me 1 is the first term there, over 1 minus the common ratio, which is 3/4. Plus, now this one, the first term is going to be 1 times 5, or 5, over 1 minus 1/4. But if this were a 1 or a 2 or a 3, you'd need to make that adjustment. 1 minus 3/4 is 1/4. 1 divided by 1/4 is 4. Plus, here we're going to have 1 minus 1/4, which is 3/4. So we end up with 5 times 4/3. So we have 4 plus 20 over 3. This would be 12 over 3. So 32/3 is our sum.